All right, example 3 from 8.1 on perimeter, where we have some plots of land here, and we have n plots of land. So we don't know how many plots of land there are. We just have a general idea of what's going to happen here. And each of those plots of land is a W by H rectangle. So we can kind of see this picture here that's given to us to kind of illustrate what's happening. And all those rectangles are next to each other, as shown here. And then a fence is going to be built to surround and separate. The key here is separate, which might be an oversight here once we get going. We're going to separate the plots. So that means that every single one of these rectangles is going to have fencing around it. It's not just the whole rectangle here. So that might be something that could be an oversight if we're just kind of maybe jumping to conclusions. And so we have to determine how long of a fence is needed to separate these n plots of land that are congruent rectangles that are W by H units long. So we can kind of make a table here. So let's just say we have one plot of land. So let's just say it's just this one rectangle here. If we have just this one rectangle, the perimeter of that rectangle is going to be 2 H's, because there's this H here, this H over here, and then plus 2 W's, because this length here is going to be W, and this length here is going to be W, because rectangles have opposite congruent sides. So if it's just one plot of land, it's going to be 2 H's plus 2 W's. That's how much fence we're going to need, depending upon how long the W and the H are. We can extend this to say, well, what if there are 2 plots of land? Well, if there are 2 plots of land, that's this right here. Now we're going to need 3 H's, because we have the 1, 2, and 3. And then we're going to need 4 W's, because we have this W here, 1, 2, 3, and 4. So you'll notice here that we don't need 4 H's, because this one side length is shared by the 2 rectangles. So we have 3 H's plus 4 W's to kind of separate 2 rectangles with the fencing. If we go to 3, it's going to be 4 H's plus 6 W's. So the 6 W's come from the 1, 2, 3, 4, 5, 6. We can see those. But then it's just 4 H's, 1, 2, 3, 4, because we have rectangles that are sharing a side length. So we don't need to double fence that. It's just happening once. And if this trend continues, we might be able to see a pattern at this point that the W, we're multiplying W by twice the number of plots, because every plot is going to need those 2 W's. We're multiplying the H by the number of plots, but then just plus 1. You'll notice that 3 plus 1 is 4, 2 plus 1 is 3, 1 plus 1 is 2. And that's because of the fact that these rectangles are sharing a fence or a side. So we don't have to kind of double up on that. So that's why that's not expanding or increasing like the W's are there. So what's happening here generally is that if it's n, we're going to take how many plots those are and add 1 to it and multiply it by h. And we can see that pattern here. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and that's because of the fact, again, that these rectangles are sharing a side of the fence. And then the W is going to be multiplied by the number of plots times 2, because those are being added on. 2 more are being added on for every plot. So that's going to be the number of plots times 2, and then times W, which is exactly the pattern we see here. So if there are n plots of land, how many ever plots there are, if we're going to have 15, 20, 30, 100, we're going to take the number of plots, add 1 to it, and multiply it by the height, or the h, the length of h, and then add that to the number of plots times 2, because there will be 2 of those added for every n, and then multiply that by however long W is, and this will be the perimeter of the fence, or how much of a fence is needed. It's not necessarily the perimeter of this thing, because we have these separated plots there. So this right here, and the quantity, n plus 1 times h, plus 2 times n times W, will be how much fence is needed for these n plots of land.